My name's Anton. I'm a principal solutions architect at AWS, taking care of serverless. Debasis is my peer, basically me, but in a different location. And Gautam is our peer at HashiCorp. Today, we're going to be talking to you about accelerating serverless deployments using HashiCorp Terraform on AWS. Now, the first question I want to talk about is, why do we even need to have this session? What's so special about those serverless applications that we have dedicated 30 minutes to talk about it? And the thing is, the answer is, when you're building serverless application, the concept of infrastructure is a little bit redefined, right? Yes, you still have that slim infrastructure layer where you deal with VPCs and RDS instances, basically the traditional infrastructure that the infrastructure team is responsible for. But the bulk of your application is a collection of serverless resources like Lambda functions, SQS queues, event bridge routing rules. And those assets are something that the application team, the application builders, really want to control because they consider it as part of their applications. So in serverless world, it's pretty common for application developers to use infrastructure as code tools. And what's also important is that in serverless world, infrastructure as code, IAC, can also stand for integration as code, because those arrows between blocks, you also define them with infrastructure as code tools. Now, this brings us into this interesting world, right, where application developers are saying, this thing is an application resource, right? We don't think of it as a traditional infrastructure. We need flexibility to control it. And the infrastructure team, on the other hand, is saying, no. We do everything in our organization using infrastructure as code tools, such as Terraform, right? We set the rules. So discussion becomes quite interesting. Now, this is definitely not the right place to talk about what Terraform is. I imagine you all know what Terraform is. So the goal of our session today is to actually explain how Terraform and serverless work together in harmony to actually accelerate those developments. Now, in order to illustrate that, what can be better than actually let's start building something, right? And Debasis, you want to take us through this segment?
Absolutely. So I'll put on my builder's hat, and we will actually build a serverless application together, right? So let's take an example of a simple serverless application, right? So this is how it looks like. This one is an example of an asynchronous image processing app. So in this particular app, we have a SQS queue that basically acts like a request buffer. So every time there is a message in the SQS queue, the Lambda is going to poll it. Based on the data provided in that particular message, it is going to take an image from an S3 bucket, process it, create an HTML greetings card, or processed file, you can say that, and put it in a destination bucket, right? So this is the example of like what we are trying to build today. And we are going to see a lot of different aspects of this particular building process. Now let's start with like creating our resources, right? So the first one is building a set of S3 buckets. And remember that we are working on the highest level of abstractions, right? So you, as a builder, for you, AWS has assumed a lot of good best practices, and it is also taking care of like resiliency, scalability, and operational excellence. You, as a builder, you need to understand the best practices and tailor them into your infrastructure as code as part of the configurations. So if you see here, with S3 buckets, I'm defining who can control my S3 bucket and who has the access to read and write objects into my S3 bucket. Very, very important. I'm working backwards from the best practices. You can find the best practices in the QR code as well. So I'm working backwards from the best practices and implementing them using Terraform. Going forward, so if you look at the SQS queue, I have taken an example of another best practices, which is server-side encryption. So when I'm building an SQS queue, I'm also keeping in mind what is the best practice for the SQS queue. And next step is to create a Lambda function. Just before creating a Lambda function, we are creating an IAM role, and we are also adding some additional best practices there as well. So if you see here, I'm basically following the principle of like least privileged access, right? So if you see the IAM policy I'm creating, that will be used by the Lambda function to do the image processing. I'm only allowing the Lambda function to read and write data from my source and destination bucket. So all you have to do as part of like being a Terraform builder, you just need to understand what are the best practices and tailor them in your infrastructure as code. Next stop, creating the Lambda function. So you can create your Lambda function in a variety of different ways. Starting with like you can write your source code in any type of programming language of your choice. and then you can basically zip it, and you can upload it as part of your Lambda function creation. You can also provide the local file reference to Terraform as well. It'll zip it for you, and it'll create a Lambda function for you while you are deploying or applying your Terraform configuration. The next step is you can also create a zip file and then upload it to an S3 bucket and pass the reference of that S3 file in your Terraform infrastructure as code, right? And the final way of creating a Lambda function is to create a container image, like an OCR container image, push it to ECR, which is Elastic Container Repository, pass the reference of that particular ECR repository location to your Terraform configuration, so Lambda can be built using that container image. Now, this is how the Lambda function Terraform configuration looks like. So you have the zip file location on your local machine. Then I have given a couple of additional configuration. For example, the Lambda function name, the file handler, the runtime, the memory, and the actual location from where the zip file will be picked up. Now, as an alternative, if you see here, you can also pass the S3 location to your zip file if you choose to put your file on S3 bucket, or you can also pass an OCR container image location as well, right? So what after development, right? So the very next step is to test your application. That's where AWS SAM comes into the picture. AWS SAM is AWS's proprietary tool that helps you emulate a Lambda function in your local machine. We do have a cool demo as well for you in order to understand like how you can use SAM to test your Lambda function. So if you'll see over here, I have a couple of tools installed on my local machine, like AWS CLI, Terraform, and SAM right over here. So before I deploy my application, what I would do is basically take a look at like how my folder structure would look like. So after you verify like all the necessary tools are available with you, I'm going to do a quick tree real quick. Let's see. It will basically describe all the folder structures and modules that I have in my project. So if you see, I have like API Gateway, Lambda, a couple of different serverless resources as part of my project. Then I'm testing my Lambda function in local. This is the important part where I'm defining the hook name as Terraform. So SAM can understand that my IAC is written in Terraform. It is going to emulate that. And what you see over here in the rectangular box is the testing results of my Lambda function in my local machine. This is exactly what you see on the CloudWatch logs as well when you actually run your Lambda function, right? So you basically take Terraform and SAM, you can develop it on your local, you can test it, and then you can push it to your actual development or QA environment. But how do we scale from there? That's where I would like to invite Anton.
Thanks a lot, Debasis. So cool demo, right? And actually pretty cool that Debasis knows all this stuff, right? I wish I could grab him and clone Debasis and basically have Debasis at every single one of my 70 development teams, right? Unfortunately, not exactly possible, right? We're still not good on cloning. But how do I get those best practices? How do I get that knowledge across my development organization? So when I'm talking about scaling here, I don't mean, how do I scale my application from processing 30 requests per second to processing 300 requests per second, right? Serverless will take care of that. I'm talking about how do I scale my knowledge? How do I scale best practices, organizational policies? How do I make sure that every single team can leverage that without actually asking them to learn it? And you know why? Remember the first slide. We're no longer talking about one team that deals with infrastructure and that's their bread and butter, they're infrastructure experts. We're talking about multiple engineering application development teams that now need to learn how to use those tools as well. So the practice that you're probably very familiar with in Terraform, right, and we see it extremely successful with serverless applications, is modularization, right? So the rule here is obviously don't put all your infrastructure as code configuration in one file. That's not going to scale, right? Modularize it, right? Organize it as a collection of reusable modules. Now, what does it give you specifically for serverless, right? 3 things. First of all the best practices that Debasis just showed you, right? You can now take that as a module, right? And everyone who's using the Terraform module is starting to get those best practices implemented as well. They don't need to understand the internal implementation specifics, right? They're just getting that because they're using the module. Reusability. Once you have that as a module, you can reuse it many, many times across different applications. So you can create that approved S3 bucket or a baseline Lambda function module, and you can reuse it across multiple projects, multiple applications. And the third one is composability. Once you've created modules for different application patterns of your serverless architecture, you can actually start composing them, right? Creating a higher level architectures. Now, let's take a quick walk through all of these three things, right? So let's start with, what would a very simple Terraform module for a Lambda function look like, okay? And those of you who are experienced with Terraform modules, you can probably take a look at that and say, that's one pretty useless module, right? You're just taking two variables and you're using them in my resource as properties, right? So that's not exactly valuable. Well, I will push back, but just a little bit, right? If you look at the runtime variable, for example, it has a default value. This is like standard Terraform stuff, right? Pretty straightforward. But this is very important for application developers, right? Because now you, as the module provider, as the platform team, you can actually instrument the best practice of using a particular runtime version. And when Node 20 going to be deprecated a few years in the future, you can actually update the module with the most recent Node version at that point in time. And now all of your application teams are getting the updated module, right? Connecting that to what you've seen in the keynote today, right? The module lifecycle management. Now, let's extend this a little bit further, right? So let's say we're adding one more variable, and that's log retention days, right? So you can also see the default there, 14, right? By default, if you do not specify it explicitly, right, the default, not the module default, but the default is actually forever, right? The question is, do you want to keep those logs forever, or maybe your organization has some policy of its own, right? How long you want to store those logs. So again, by using the module, you're no longer delegating that decision to every single team. You're no longer forcing developers to make that decision. You're providing them the default that your organization decided on, but that's a variable. They can override it if they need to, but only if they need to. On the right side, on the other hand, you can see that things are starting to get much more interesting, right? It's not just variable to property mapping. Right, we're creating a bunch of different resources, additional resources like log group, permissions required, configuring Lambda function. So essentially, by exposing a single variable, you've encapsulated a lot of business logic that your developers don't need to be, don't need to worry about right now. Let's take a look at a couple more examples, right? So since we already discussed logging, right, you probably want to have some sort of standardization across multiple functions, and this can be thousands, maybe tens or hundreds of thousands of functions. You want to have some standardization, let's say, about the login format, right? Why? Well, because it's much easier to debug your applications if all of them are emitting logs in a particular format, right? You know how to query the logs. So by adding something as simple as that to your module, you just standardized all the logging across Lambda functions in your organization. Another example, Power Tools. Right, Power Tools is an open source framework that we provide free open source on GitHub. Essentially, it's a framework that encapsulates a lot of best practices that we've learned over the years for developing Lambda functions. Now, your developers with this approach, right, they don't need to figure out where to get the latest version on their own, because all of that is part of the module. So what's next, right? So you've created those best practices. Right? You've created the module, you published it, you defined what would be the interface, the variables. Now you can control things like function name, memory size, a runtime handler, whether this function should be attached to a VPC or not. So you're providing sane defaults, something that your organization has standardized on, right? And you're also allowing your developers to override that, shall they need to override that, right? So what happens next? Next, you start to create, control those modules that essentially encapsulate functionality that you need for different use cases. So we've already seen the baseline Lambda, right? This is just one of the use cases, right? Lambda function that implements best practices. What about Lambda function with periodical scheduler, right? Probably at least half of the rooms have some scenario where they need to do like hourly or daily reports generation, right? Or data processing, something that runs on intervals, right? Instead of asking each development team that needs to implement this scenario to, hey, go read docs, right? How do you actually create a Lambda function that runs hourly or daily? You can create a module that will provide Lambda function with periodical schedule. Done. You address that problem for the whole organization and the platform team. Another scenario is SQS queue with redrive, right? For those of you who used SQS, it's a serverless message queue, right? You can push messages, but sometimes the consumers of those messages are failing to process those messages for various reasons. Can be network hiccups, can be some bugs in the code. There are different reasons why a message cannot be processed. What happens in that scenario? Do you drop the message and lose the data? Do you retry? So DLQ, that letter queue, actually helps you to address that scenario, right? So the messages that consumer cannot process after a predefined number of retries will go to DLQ, to that letter queue. So you're not losing data, and you know that you have a designated place where the data that failed to be processed is stored, right? This is excellent best practice for not losing data when using messaging system. Why can't we just encapsulate it as a module, configurable module, and provide to my application teams? And let's take a look at very fun thing that we're getting here, right? We got Lambda function with periodical scheduler. We got SQS queue with redrive, and you have a baseline Lambda function. So essentially, imagine the report processing or periodical workflow. The Lambda function is triggered daily. It gets the data from some data storage. It pushes the processed data into SQS queue, right? And then you have another Lambda working asynchronously, pulling data from that queue and processing data. So essentially, what's the difference between these three boxes, which are three decoupled Terraform modules and end-to-end architecture, right? Take a look. The difference is 2 arrows. That is it. Okay, you can create your application module using those 3 lower-level modules, and this way, those Terraform modules become an application architecture. Let me show it again. Can we go one slide back? Right, those are 3 different modules, right? Decoupled, unrelated modules, and this is application architecture, right? That's the idea of reusability and composability. Now, the next big question is, who's actually creating those modules, right? Whose responsibility this is, right? Because Terraform traditionally been infrastructure's team thing, right? And now we're seeing that application developers are using it. I'm a solution architect, so obviously the right answer is it depends, right? But what we're seeing very common is that those modules are usually started by the platform team, right? Because let's face it, platform teams are much more experienced with infrastructure as code tools. But gradually, the application development teams, they're not just consumers of those modules. They're also contributors, right? So we do see scenarios where application development teams who want to have more control over what they can do with their application are starting to contribute to those modules, right? Maybe infrastructure team or platform team are still not okay with application development teams managing RDS, right? Understandable. But hey, you want to manage your Lambda functions, you want to manage your event bridge rules, use the modules we provide you, and you can do whatever you want, right? You can do fully self-service. Now, we're seeing this, what I call maturity kind of level, right? The progress. So when we see customers starting to use Terraform for serverless applications, I call it maturity level beginner. It's not like official term or anything, right? We see that they're starting with using Terraform resources, right? This is probably the most beginner approach, right? I was there, everyone was there, right? So this is where you start when you're building your applications with Terraform, your infrastructure with Terraform. The next thing that you learn quite fast is how to use Terraform modules, right? Maturity level advanced. And this is where you start to create modules for particular, not application specific, but particular patterns that you use in your organization. Things like SQS with redrive, periodically invoke Lambda, VPC attached Lambda, and so on, right? So I call it maturity level advanced. And where you want to get next is when you're building applications using Terraform. So you're creating an application Terraform module. And that application module is actually built from the vetted Terraform modules, right, that you've seen on previous screenshot, right, or some of those modules can also be found in the open source community. So that's what I call power user. When your applications are not composed of directly using resources, but composed of using vetted modules that either platform team or someone else as a development team in the organization has created. Now, when we talk about open source, there are multiple ways, multiple locations you can get that open source. One of the prominent ones, right, is serverless.tf. Right? If you're using AWS, you're most probably familiar with AWS Terraform modules project. So this is a subset of that project. Okay, and they have about a little over a dozen different Terraform modules for serverless resources. So that's available online, over 120 million downloads. Right? Feel free to look at that. So we looked at building applications, testing applications, scaling best practices across organizations using Terraform. And the natural next question is, how do you deal with deployments?
All right, thanks, Anton. So I'm here to talk to you guys about consistent deployments. Right? I think it's safe to say that all of you are in different phases of your maturity journey with Terraform. And a lot of you might already be doing what Anton spoke, right? So using a mixture of self-built modules and community modules. When you go through that journey and we actually deploy those modules, there's a different kind of problem that arises, right? I'm using HCP Terraform here as an example. You might have seen some of these slides before. But essentially what happens is the same infrastructure as code is running in different environments, whether it's your QA dev test or different BUs kind of using the same things. And this is especially true in serverless, right? As Anton said, there's a separate responsibility model with when it comes with serverless, right? And talking about those sort of challenges, there are multiple teams, infrastructure teams, as Anton was saying, kind of sharing the core infrastructure resource, as we call them, like VPCs, your RDS instances, load balancers, right? And the app dev team sort of owning all the serverless assets, like Lambda functions, event bridging rules, and those application components. Now, those teams need to automate dependency management and learn how to work in a reliable and consistent manner. You also might have multiple environments, like application team creating replicas of their environment in like dev, staging, prod, multiple account where you have different BUs, so you want separation of account principals, IAM roles, and those sort of things. And multiple regions. You want your app to be highly available across US East 1, US West 1, Europe, Asia Pacific, those things. So I'm very excited to talk to you guys about Stack and how it can help with your serverless applications. And Stack, as you've heard earlier this morning, introduced a new way to deploy your infrastructure by allowing users to not only describe what you want to provision, but how and where you want to provision it, right? And the what that I'm talking about in this equation is defined by the new file, the components, right? Each of those are a Terraform module, right? For example, network, compute, and database will all be like components. The how and where would be defined by declaring deployments. So it tells Terraform how you'd like this collection of components to be deployed. So what does this actually offer us in the serverless world, right? You might be asking, okay, we've heard about this. Like, what does it offer in the serverless world? It makes it really easy for teams to have that separation of responsibility, like Anton was talking about. In the serverless world, this translates to the infra team owning the common services stack and application team owning the application development stack. So when the infrastructure team kind of makes changes upstream, Terraform automatically triggers those to the downstream stack. And it makes it really easy for both of these teams to kind of seamlessly work together in a very consistent way. So what I'm going to do next is I'm going to translate, some of the things that Anton talked about, some of the things Debasis talked about, and take a serverless app and make a stack out of it, right? Kind of show you real life how that translates into stacks. So I have 3 stack components here: my API gateway that will expose my application, my Lambda, where the code will actually run, and my S3 bucket, which will store the assets for the application. We'll see more of the components in the demo section, but this is how my deployment definition will look like. As you can see, deploying in different environments is just a Terraform block away. Like it's not too complicated. You don't have to create a different workspace or have folder separations, all of those things, right? And what you really get out of that is, your deployment and, the high availability pieces I was talking about earlier. So in this example, the development stays in US East 1, and my production is kind of replicated across US East 1 and US West 1. All right, enough talk. Let's look at the demo. Let's see how that kind of goes. So here I have my component. Let's see. And the region just becomes an array, right? So you can loop through those regions. This is my S3 component. The output of the S3 component becomes the input for my Lambda component. So it's very easy to reference like cross-module. And next, we're going to look at like the deployment file, right? So you can easily see, my regions is just an array of string. So that's how easy it is. You want to deploy in Asia Pacific, just add, Asia Pacific to that array, right? You also have this separation of role arms, right? So you can have a separate set of policies and IAM roles that you can define for your development use case versus your production use case. So running this in HCP Terraform, it's going to look at the configuration, start the run. Behind the scenes, it's doing normal Terraform stuff. So it's downloading the source code, downloading the provider. It's also analyzing and understanding what needs to happen with these plans, right? In the keynote today, Armand mentioned deferred actions. It kind of understands, what needs to be provisioned first before the lower layer of infrastructure are provisioned. So here, if I look at my development plan, I can look sort of more deeply. Terraform already understands, OK, S3 needs to go first, then Lambda, then API gateway. And as normal Terraform workflows, you can approve that plan, kind of proceed with that. Once the deployment is done, we can actually see that the app kind of goes live. So right about here, I'll kind of go through the API gateway, ping that gateway, and see that my app is live. All right, so that's it for the demo. For the conclusion part and kind of send you off with a nice message, I want to invite my co-presenters here and take you through the conclusion.
Sure. So yeah, start using Terraform, the tool you are already familiar with, and then adopt tooling like either SAM for your local testing or any other tool for like your local testing, and rapidly build your serverless applications. Thanks.
Modularizing your Terraform configurations using existing open source modules and modules that you create in your own organization. It allows you to build reusable patterns, which are critical in the serverless distributed world, right? So essentially, it allows you to scale your development organization using Terraform.
And when it comes to serverless modularity, scalability is key, as Anton said. Stacks make it really easy for teams to deploy your serverless application and resolve those cross-team dependencies.
Thank you so much. We got few QR codes for you if you want to continue learning. We have building serverless applications with Terraform guide, workshop, documentation, a lot of materials. There will be dedicated sessions at reInvent if you're attending. And go build something awesome with serverless and Terraform. Thank you so much for coming.
Thank you.